Yes, good afternoon to all the students. Let us start today's class. So we are dealing with converter circuits. Yesterday we have taken fully controlled converter with resistive load. We have seen the explanation. The derivative part will concentrate later on. So today's class is all about fully controlled converter with inductive load. So we are having three different types of loads as per the syllabus: resistive load, next RL load, and next followed by the RLE load. So E represents the back EMF of the motor. So is the voice audible? Any student confirm?
Yes, sir.
Right. Now, so in the external examination, every one of us can write easily the resistive load, but most important application is with respect to the explain the operation of fully controlled converter with RL load or inductive load. So today's class, we see the explanation beyond the textbook range and what exactly in simple manner we are supposed to put the explanation of the fully controlled converter. Let us have at this one. Right. So very first point I want to clarify. If you see the different textbooks, they mention two different type of circuits for fully controlled converter. So anyone tell me the application of fully controlled converter? Fully controlled converter controls the speed of motor in how many directions? Anyone? In forward direction as well as in backward direction. Okay, one student, please mute. Disturbances we are getting. Right. So fully controlled converter can control the speed of the motor in both the directions. It operates for an angle 0 to 360 degrees. The fully controlled converter operates for positive off cycle as well as the negative off cycle. These 3 points are common points. Now, fully controlled converter operation with inductive load we are discussing. Okay, right. We'll check that one, inductive load. So if you see on the screen, you're having two different circuits. Both are fully controlled converters only. But here, if you see the right hand side, resistor and inductor in series, okay, which is not the appropriate representation. So in what way we have to represent in the examination or in the industries? The first inductive load. Inductive load is represented by the inductor followed by the resistor. So what exactly this L and R? It should be represented first inductor and then the resistor. This left side circuit is the exact correct circuit. We have to put it in the examination. So fully controlled converter with RL load, or the exact name is inductive load. So whenever we put L in the circuit, the L in the circuit represents, you can see on the screen, motor winding inductance. So inductive load means, let us take the example of motor. Motor has got the armature winding and field windings. So those field and armature windings are represented by this particular inductor. Not only the winding inductance of the motor, it L represents motor winding inductance plus external inductor. One second. Srilata, please mute yourself. You are getting disturbance. Okay. Right. So what does this L stands for in the fully controlled converter? So very often, the soon after representing the circuit, you should mention L represents what? L equal to motor winding inductors, that is armature winding and field winding plus external inductor. So in our circuit, the L represents this particular combination. So what is this external inductor? Why we have to use this word? So our ultimate aim is to control the speed of the motor continuously. So the motor should not be stopped at any instant of time. So we should concentrate on a word called continuous current. So all the power electronic circuits are designed to provide continuous current only. So what is that continuous current? The current which flows through the load at regular intervals of time without reaching zero value. It is called the continuous current. So for simple difference, if you see this particular graph, the right side what we are having, you can see the AC sine wave, it is increasing and decreasing, but it is not approaching the zero axis. It is not touching the x-axis. So this type of currents, which are called the continuous current, the currents which are continuously flowing at regular intervals of time without having a zero value. This is called the continuous current. But what is discontinuous current? You can see this left-hand side figure here. The current is increasing and decreasing, and it is approaching the zero value at certain interval of time. So if the current reaches zero value at any instant of time, that current is said to be discontinuous current. If discontinuous current is passed to the motor will stop at any instant of time. So always we are developing the power electronic circuits to provide the continuous current. So in power electronic subject, we deal with the circuits and the explanation in order to have the continuous current. So let us go back to this particular slide. So that's why what points are missed out in any textbook if you study. So first, clear-cut definition of continuous current. Before we explain fully controlled converter in the examination, we must highlight which circuit is the right one. And just after drawing the circuit, okay, many people will represent the circuit, but what exactly the inductor stands for in the circuit? Inductor L is equal to motor winding inductance, which means armature inductance and field winding inductance plus external inductor. Yes, external inductor means what? Why you are using to provide. External inductor is used to provide the continuous current. So why we require continuous current? Just now we have discussed. So the current which flows at regular intervals of time without reaching the zero value is called continuous current. And which inductors provide this continuous current? So very large values of inductors only provides continuous current. So if you want to design one converter, if you want to control the electric car position, if you want to control the lift position, you must place the converter circuit, okay? But in that converter, along with the motor, you must add one external inductor, which value is very much large. We will see that what is the practical value of that inductor. Very small values of inductor provides discontinuous current. If in my circuit, imagine I'm not placing this external inductor, then what's going to happen? Can you control the speed of the motor continuously? No. This is the objective type question which has been asked in the GATE examination and different competitive examination. Continuous current is provided by dash arrangement, very large values of inductor. And discontinuous current will be obtained if you are using very small values of inductor. So fully controlled converter, when you are explaining in the examination, just after drawing the circuit, you must highlight this point. Inductor L stands for, or L is equal to motor winding inductance plus external inductor. External inductor is very large value of inductor which is used to provide the continuous current. If continuous current flows through the motor and the circuit, then only the motor rotates at regular intervals of time. I hope this point is clear. So this right hand side, what we are representing is not the updated one. First, we must show the inductor and this particular resistance. What exactly the resistance stands for? Inside the motor, we are having winding, armature winding, field winding, and resistance. This resistance actually represents armature resistance of the motor. And this inductor represents field winding, armature winding, and external inductor of the motor. Okay, I hope this point is clear. This is the new thing which every student has to be perfect. So fully controlled converter contains 4 SCRs. Why we have to use the 4 SCRs? Why not only 2 diodes and 2 SCRs? Means if you are using 4 SCRs only, you can control the speed of the motor in forward direction and in backward direction. Electric train can be moved in forward and backward direction only with the help of the fully controlled converter. So that's why the name stands for fully controlled converter, which can be operated for positive half cycle and negative half cycle. So today's class, let us concentrate the explanation of this circuit, fully controlled converter with resistive inductive load. Inductive load means LR load. Okay, right. So in order to discuss this one clearly, let us share the new slide. Okay, so all students be activated now. I want the explanation from both the ends. Okay, so being a power electronic engineer, we got a huge scope across the world in power electronic subject only, as you people also know. Come on. So why 4 SCRs we are using, we know. So one more question. Which two SCRs I can turn on simultaneously? Anyone tell me? Which two SCRs I should turn on simultaneously in fully controlled converter? So answer is diagonal parallel SCRs. Yes or no? T1, T2 we can turn on at same instant of time with single firing pulse. If single firing pulse is used to turn on two SCRs, that is called dash triggering, symmetrical triggering or symmetrical firing. If I am using same pulse for T1 and T2, then it is called symmetrical triggering or symmetrical firing. If I am using different pulses for T1 and T2, it is called asymmetrical triggering. So all these are objective type questions, remember. So in a fully controlled converter, which two SCR should be fired or turned on at same instant of time? Anyone? So always diagonal parallel SCR should be turned on at same instant of time. If I am turning on T1 and T3, we cannot convert bidirectional current to unidirectional current. Okay. So if you are turning on T1 and T4, we cannot convert bidirectional to unidirectional. In fact, we lead into the short circuit condition. So what is the explanation? All students ready? Okay, come on. So let us say this is the terminal A and this is the terminal B. Instead of using the word phase and neutral, explain the fully controlled converter. So this explanation I will repeat the number of times, but everyone has to remember this explanation. Come on. So how to explain this fully controlled converter? The first two points already it is clear. Inductor, why you are using the inductor? What does the resistance means? Now I want the explanation here. Come on, I'll repeat for one time. So in what way we explain first? During positive off cycle of input AC supply, voltage at point A is greater than voltage at point B. So I have written here the first line, you can check it out. Every student without studying the textbook can become perfect here. So what is the first statement, all of you? During positive off cycle of input AC supply, voltage at point A is greater than voltage at point B. Therefore, direction of current starts from which point? Point A. So you can have the current starts to flow from A. For SCR T1, what's going to happen? Just like yesterday's explanation, it is same. For SCR T1, anyone can unmute and tell me the answer? For SCR T1. SCR T1 is turned on, good. But what is the explanation? For SCR T1, current enters the anode terminal first. Therefore, the voltage at anode is greater than voltage at cathode, and hence the junctions J1 and J2, J3 are forward biased. Now, with the help of UJT, we apply firing pulse at the gate terminal of SCR T1. Now, all the three junctions are forward biased. Now, finally, the SCR T1 is on. So current flows through the T1 and then current flows through the load, and from load to the T2, T2 to the B. So we kept here. So during yes, current direction of the current starts from A to T1, T1 to load, load in the sense inductor, resistor now to B. During this process, this is important now. During this process, inductor energizes. Okay, so now I'm just putting out here. Let me share again. This inductive load will be somewhat complicated, but you must listen number of times in order to have the exact understanding. So we just move on to this slide. So before we study the inductive load, we should write certain points regarding the inductor, property of inductor. So if somebody asks you what is an inductor, people say inductor stores energy in the form of magnetic field. But as an engineer, that too as an electrical engineer, what is a property of inductor? In the external examination also, in the theory points, you must put this particular words, property of inductor. So whenever, now the load is what? Inductive. So whenever current flows through the inductor, inductor energizes, that is inductor stores energy in the form of magnetic field. So current flowing through the inductor cannot be changed suddenly or instantaneously. So current flowing through the inductor will not increase suddenly or will not decrease suddenly. It increases or it decreases exponentially or gradually. So whenever current flows through the inductor, inductor energizes. That is, magnetic field is going to be stored across the inductor. So these are the three lines we have to write here as soon as we see the inductive load. So 2 to 3 times explanation only, this topic people will get perfect, especially with the inductive load. So what is the statement here? During post off cycle, current flows through the supply T1 and T1 to load to the B. But during this process, yes, here we have written, during this process, inductor energizes and starts to store energy in the form of magnetic field. So this point we have read. So now inductor is energizing. So when inductor energizes, okay, one more point we have not written here. You must put it in the examination. Okay, I'll provide the material. When inductor energizes the motor which is connected to this fully controlled converter circuit, the motor starts to accelerate. I want to start the electric car, let us say. Inside the electric car, I am having the power electronic circuit. So current flows through the power electronic circuit, current flows through the inductor. Inductor energizes. When inductor energizes, that particular motor where the inductor is connected, that motor starts to energize and gains the kinetic energy. So remember this point, during the positive off cycle, current flows from A to T1, T1 to load to T2, T2 to B. During this process, inductor energizes and motor accelerates. As a result, motor gains the kinetic energy. Now, motor is ready to move from one position to another position. Is it clear, all of you? Okay, this is the first point. Now, let us go with the graph now. Okay, so I'm just trying to draw here the graph. All of you see, you can practice later. Right. Just have a look at this diagram first. So we have to explain the entire explanation with respect to the graphs. So first, let us draw the input. So input is, I'm just drawing the input signal graph diagram. Input is, yes, any question? Monica raised your hand. You can ask the question, unmute, or you can put it in the chat box. Question edunna adagandi evarena. Okay. So we are having the input AC supply. So now, so what we have to do next, in order to turn on the SCRs, we have to apply the firing pulse. So firing pulse I am applying. I can select the angle from here 0 to 180 and from 180 to 360. So now I am applying the firing pulse. So one more question. In order to have maximum speed of the motor, what should be the firing angle? Firing angle means the angle at which all the junctions are forward biased and SCR is on. So what is that angle? It is called firing angle, denoted by alpha. Let us say at alpha or omega t is equal to, here it is omega t x-axis. This is the firing angle I am choosing. That means the SCR will turn on at this firing angle. So let us say at this point I am applying firing pulse to the SCR. SCR is turned on. Which SCRs? T1 and T3. Now what will happen? The movement will turn on. So it is from 0 to 180. So now when SCR is on, it transfers the input energy to the output. It transfers the input energy to the output. This graph is following this input signal. So now what is the explanation here? So this is the output voltage. I put here the representation. This particular thing here, it is nothing but, I kept two dots. Okay, this is nothing but V0. V0 stands for what? Output voltage. This is the input voltage. This is the firing pulse. But when we are having the inductor, now let us study the basics regarding the inductor. The current flowing through the inductor cannot be changed suddenly. So what's going to happen? Let us go back. We have written here clear. So what is the theory explanation? During positive off cycle, yes, the T1 and T2 are on, current flows. During this process, inductor energizes and starts to store the energy in the form of magnetic field. That graph you have to explain. Now see, all of you, you must explain in different cases. Case 1. What is case 1? Anyone read out? At omega t is equal to alpha. I cannot put here alpha, the trigonometric value. So I have written in a statement. At omega t is equal to alpha equal to 30 degrees. We are assuming pulse signal is applied to SCR and SCR is turned. SCR is triggered. Now the SCR starts conducting and transfer the energy from input to output. So at omega t is equal to alpha, what's going to happen? The SCRs T1 and T2 are on, current flows through the SCRs, current flows through the SCRs. Okay, so now this is what we have represented here. So this graph is explaining at this point that T1 and T2 are on, current flows through the SCR. So what's going to happen? Since we are using the large values of inductor, so let me draw for this one. Okay, of course this one. So inductor current flowing through the inductor will not increase suddenly, will not decrease suddenly. So current flowing through the inductor will increase exponentially. So in this manner, the current flowing through the inductor will increase. Now this is 180 degrees. At 180 degrees, case 2, what's going to happen? Input voltage is 0 and output voltage is also 0, but the current value is not 0, it is maximum. So this point every student has to be perfect. So what is the explanation? How to explain this fully controlled converter? Case 1. Okay, of course the basic theory is during post off cycle T1, T2 are on and current flows from A to B. That is done. During this positive off cycle, inductor energizes, the motor starts to accelerate and the motor gains kinetic energy and the motor is ready to rotate. Okay, at omega t is equal to alpha equal to 30 degrees. Imagine this is the 30 degrees. At 30 degrees, we are applying firing pulse to which SCRs T1 and T2 both are turned on. Okay, when they are on, they transfer the energy from source to load. Energy is transferred from source to load. Okay, but what happens to the current? So what is the nature of the current? Inductor current flowing through the inductor cannot be changed suddenly. Therefore, at omega t is equal to alpha equal to 30, inductor starts to store the energy, inductor energizes. So I should put here. So what's going to happen at case 1? Inductor energizes. This is important here, all of you. So I'm writing here inductor energizes. At which condition? At omega t is equal to 30 degrees. Let us erase this one. Okay, is it clear all of you? At omega t is equal to 30, what's going to happen? Examination, you will get full points if you are writing this case as case 1. Case 1, omega t is equal to 30 degrees. Here we are kept. And at 30 degrees, SCRs are on, inductor starts to energize. Remember this point in a simple language. Case 1, at omega t equal to 30 degrees, inductor starts to energize. Inductor starts to energize. That means it stores the magnetic energy. Now any student, try to explain this one. Case 2 at omega t equal to 180 degrees. So I'll just put here. So what's going to happen at omega t is equal to 180 degrees? Anyone try to tell me? Omega t is equal to 180 degrees. At 180 degrees, what's going to happen? What is input voltage? Anyone tell me? Input voltage is how many volts at omega t is equal to 180 degrees? 0 volts. Yes or no? Input voltage is 0. Anyone tell me this one? What is the output voltage? At omega t is equal to 180 degrees. Output voltage is also equal to 0. But current is not 0. Current reaches the maximum value. So here we have represented omega t is equal to alpha equal to 180. Current flows through the inductor reaches maximum value, but both input and output voltages reach 0 value. So SCRs are not turned off. So what's going to happen after 180 degrees? After 180 degrees, now the inductor starts to de-energize. Inductor releases the stored energy from 180 to, now you see the graph. We are drawing here live graph here. I hope it is visible. Right. So inductor de-energizes and the de-energized current. Okay. Now it will not de-energize completely. It is continuous current. So this particular point is nothing but the pi plus alpha. So I hope all of you are seeing the graph. This is called pi plus alpha or pi plus alpha equal to beta. So at omega t is equal to 180 degrees, inductor current is not 0, it is maximum because we are using large value of inductor. Now at omega t equal to 180 degrees, inductor starts to release the energy, and when the inductor releases the complete energy at omega t is equal to beta. You can see the case 3. case 3, what we have written at omega t is equal to alpha equal to 180 degrees. Okay, inductor de-energizes, that is 180 degrees, which is plus alpha. Here the symbol is alpha. At omega t is equal to alpha equal to 180 plus alpha, which is called beta. We are assuming it as the beta. The inductor de-energizes completely and releases the stored energy. Now SCRs T1 and T2 are commutated naturally. The commutation we have already taken, the process of turning of the SCR. So no doubt is here, all the students. So current waveform is different. Current waveform reaches maximum value at omega t is equal to 180 degrees, and then it de-energizes. It becomes the minimum value at omega t is equal to beta. What is beta here? After 180 degrees, that is 180 plus alpha. So what's going to happen for negative off cycle? Now we are giving firing pulse to T3 and T4. Now the current starts to energize. It will energize up to which point, all of you? It will energize to 2 pi. So up to 2 pi, it starts to energize. And after 2 pi, at 2 pi, it becomes maximum, once again starts to de-energize. So this current is called the continuous current. This process is continuous. Energize and de-energize. So I'll put it clearly in the next coming class also. First class, we thought of taking the rough diagram. Okay. So direction of the current. So anyone tell me what will happen during negative off cycle, current direction? During negative off cycle, current start from which point, A or B? Come on, anyone student unmute and tell me. During negative off cycle, current starts from point B. All of you are present or not?
Sir.
Okay.
Sir.
Okay. So during negative off cycle, current starts from the point B, and from B to current flows where? So I'll just write you. Any one of you tell me. I'll just put here. What is the direction of the negative off cycle? During negative off cycle, from where the current starts? Current starts from the point B, B to T3, T3 to load, and from load to T2. From load to T4, T4 to A. So now let us go back to the animation. Then I'll get back to this one. So fully controlled converter is a important one. So let us check with the animation now. So in the animation, you will see the right. So we got this circuit. So how the current flows we have seen in the last class also during positive off cycle and during negative off cycle, the inductive load. Okay. So now we are seeing the input and output voltages, but the most important graph is nothing but the output current graph. Yes. So I hope now you will understand. So why the graph? So at omega t is equal to alpha equal to 30 degrees, we have given the firing pulse. Firing pulse is not shown in this animation. So output voltage will follow the input voltage, but the current flowing through the inductor will not increase suddenly or decrease. Therefore, it energizes exponentially. You can see here very large values. All textbooks have imagined one particular point. So current value reaches the maximum value at omega t is equal to 180 degrees. After 180, it starts to de-energize. You see here at omega t equal 180 degrees, the inductor current is maximum. Again, the inductor current starts to de-energize during the next cycle. So these are the voltages across the SCRs. Now you can see during negative off cycle, T3 and T4 are turned on. So now we say from omega t is equal to pi to pi plus alpha, there is no conduction. All SCRs are off because at omega t equal pi plus alpha only SCRs T3 and T4 are on. So this particular zone is called the reverse swing of the voltage. So here no SCR will conduct from pi to pi plus alpha. This is alpha, and pi to pi plus alpha, no SCR will start to conduct. Again, next SCRs will start from pi plus alpha. That is what we are assuming it as the beta. So if you see this particular graph once again here, so At omega t is equal to 5 plus alpha or beta, both the SCRs are turned on and inductor is energizing. That's why we are going to get the current in this manner. Okay, even for the negative pulse. So this process is continuous. Continuously, the current starts to flow through the load. Okay, I would like to ask any questions from your side, whether it is able to clearly understand or not the topic. So continuous current followed by the simple full wave converter with inductive load. All the students. Of course, you have done in diploma, but regarding the derivative part, we'll take it on later on. So, right, when you put this one here, again, you are having the clear slide. What happens at omega t equal to 30? We have seen with the graph. All the students, omega t is equal to 30 degrees. Current starts to flow through the inductor, and the inductor current energizes exponentially. At omega t is equal to 180 degrees, current reaches which value? Maximum value, whereas the input voltage and output voltage are zero. At omega t is equal to 180 degrees, once again, current flowing through the inductor will not decrease to zero, but voltage will be zero. SCR is not turned off. At omega t is equal to beta, that is beta is equal to 5 plus alpha, 180 plus alpha, current flowing through the inductor will be zero. Inductor de-energizes completely. Okay, this is highlighted in the graph as a negative swing. So I show this one once again. This simple graph is important. So how the current flows, I hope everybody know this one. So input voltage, we are having output voltage, alpha equal to 30 degrees. So what is the representation of the current? How we can represent the current? You can see output current. Current will not increase suddenly. Current increases, current flowing through the inductor increases exponentially. Therefore, here we say the current increases exponentially, you can see. And now what are these cases? You can see this is called at omega t is equal to 30 degrees. Inductor starts to store energy and current is flowing through the inductor. At omega t is equal to 180 degrees, inductor current is maximum, but the voltage value is zero. Okay, therefore, inductor stores energy certain period of time, and at omega t equal to 180 degrees, current flowing through the inductor is maximum. After 180, slowly the inductor de-energizes. Now you can see the current waveform. Observe the current waveform only, all the students. Inductor de-energizes. Here you can see. Now inductor is de-energizing. It will not de-energize to zero because it is the continuous current. So what type of inductors we have to keep in the power electronic circuit? Slow energizing, fast de-energizing. You can see the fast de-energizing, once again energizing of the inductor. Okay, when we take it in the class board, on the class board we can take it clearly. So energizing and de-energizing of the inductor, we have to represent here. So only be perfect with the input voltage, output voltage and output current. Okay, let us check this one, repeat the circuit. So fully controlled converter with inductive load, the theory explanation is what we are concentrating. So let me take the attendance first for today's class. Attendance screenshot. Put it in the chat box, everyone. Right. Come on. I want any one student to give the perfect explanation of this circuit within 1 minute. Anyone is ready? You're all diploma completed people also. Come on. This circuit. Explain the operation of this circuit. So I'll repeat for this one. Okay, the theory should be perfect. As you know, problems also will take so very soon. Right. So what is the explanation of this fully controlled converter with inductive load? Fully controlled converter can control the speed of the motor from 0 to 360 degrees in forward direction as well as the backward direction. Inductive load represents the example of inductive load is any type of motor which has got the winding. So what is the L? L stands for motor winding inductance plus external inductor. External inductor provides the continuous current. During positive off cycle of input AC supply, current starts from the point A and current starts to flow through the T1 to load and from load to T2 back to the point B. So during this process, this point is important. During this process, inductor energizes. That is, inductor starts to store the energy in the form of magnetic field. Magnetic field develops across the inductor. And now the motor, which is connected to the inductor, the motor starts to accelerate. Motor rotates in anti-clockwise direction. Motor develops the kinetic energy and then the motor starts to rotate. So after certain an inductor at omega t equal to 30 degrees, inductor starts to energize. At omega t is equal to 180 degrees. Okay, case 2. What's going to happen at 180 degrees? At omega t is equal to 180 degrees, inductor current flowing through the inductor becomes maximum. It reaches the maximum value, but the input voltage and output voltage will become 0. Since the inductor cannot release the stored energy continuously, and hence current flowing through the inductor is maximum. During this process, at omega t is equal to 180 degrees, both SCRs T1 and T2 are not turned off. They are not commutated. They are commutated at omega t is equal to pi plus alpha, which is 180 plus alpha, which is equal to the beta. So at omega t is equal to